In this lesson, you will learn how to interpret the y-intercept and slope of the least squares regression line in the context of a question. Take out your foldable that you created in the lesson on scatter plots. We'll work on this third section here. In related lessons, we've talked about scatter plots and correlation. We'll add to the discussion with slope and y-intercept in this lesson. It's a bit of an algebra review. We had y equals mx plus b in algebra land. The only thing that I changed is that we switched around where we have the slope and y-intercept in the position of the equation. Also, we have a hat on our y, meaning it's a prediction of something. So we have y hat equals a plus bx. We won't use that algebra one anymore. Our a is the y-intercept and our b is the slope. What we'll do in this lesson is talk about how to interpret these in words. In algebra, we didn't really do much of that. You found the equation of the line, you box it, and you were done. Well, now in statistics, the line itself isn't as important as how we interpret the numbers that we found. So we'll do that in this lesson. Let's look at the y-intercept. The y-intercept of the least squares regression line, or LSRL, is the point at which the line crosses the y-axis. Well, that's true for any line, but in this case, we'll be looking for what that tells us. So the y-intercept represents a point. When the x value is 0, the y-intercept is about a. It is a point 0, a being the number that we get from our least squares regression line. Let's explore this together through example number 1. 100 babies were randomly selected. Their age in months and their length in centimeters were recorded. The following is the least squares regression line for this baby data. Length hat equals 49.57 plus 2.04 months. I want you to interpret the y-intercept in context of this question. Here's the solution to example 1. What I'm asking you to do is interpret that 49.57. The y-intercept is 49.57. So remember, it represents the point 0, 49.57. That point where the least squares regression line cuts through the y-axis. So what this really is telling us is that when x is 0, my y is approximately 49.57. Now, this approximate idea is very important in statistics. I don't want to say when x is 0, y is 49.57, because then what I'm saying is when a baby is 0 months old or when the baby is born, they will be exactly 49.57 centimeters. All babies, when they're born, are different lengths. What we're doing is giving an approximation of that value. So in context of this question, we should say when the number of months is 0, the length of the baby is about 49.5 centimeters. Now those is's that are highlighted are talking about a point. When x is 0, y is approximately our value. The about portion of the sentence is taking into account that approximation. I don't know if it's exactly 49.57 centimeters, but that's my estimate for my least squares regression line. Lastly, I have the context of the question. My x variable is the number of months. My y variable is the length of the baby. So, to sum up, if I want to interpret the y-intercept, I talk about when the number of months is 0, then the length of the baby is about or approximately 49.57 centimeters. So what I'd like you to do is in your notes, put this sentence frame. When the blank is 0, the blank is about blank. This is the structure that you'll see every time you want to interpret the y-intercept. What goes in the blanks? Well, when the x variable is 0, the y variable, whatever that is in words, is about a. Whatever the value is that we got for our y-intercept from our calculator. We will do the same thing for slope. Think back in the day of Algebra 1 or Integrated 1, when you learned that slope was the change in y over the change in x. Or maybe your teacher said it's delta y over delta x, which means the same thing, change in y over change in x. Maybe somebody told you it's rise over run. All of those will help us interpret the slope. The slope of the LSRL is the rate of change of the data used to create the LSRL. So I'm really talking about this rate of change in y over change in x. On average, when the x variable changes by a certain amount, the y variable changes by a certain amount. That is my slope, and that's what I'll need to interpret. Let's try another example. In example number 2, 100 babies were randomly selected. Their age in months and length in centimeters were recorded. The following is the LSRL for the baby data. Length hat equals 49.57 plus 2.04 months. Now, I want you to interpret the slope in context of this question. Pause the video and try this on your own. Press play when you're ready to resume. Let's take a look at the solution. Look at my least squares regression line, which notice I gave you, so you didn't even have to calculate it. This is common on a test or a quiz. From the LSRL, I know that the slope is 2.04. Writing the slope as a fraction will be helpful. So don't write it as 2.04, write it as 2.04 over 1. Well, that represents the change in y over the change in x. But we're not talking about just any old x and y. We're talking about the length and the months. My y variable was length. My x variable was months. So now let's talk about this in a sentence. In context, on average, when the number of months increases by 1, the length of the baby increases by about 2.04 centimeters. Notice there's a change word. In this case, it's increases. Back in the y-intercept, when x is 0, the y is approximately something. Well, that's because the y-intercept is talking about a point. The slope is talking about a rate of change. How does x change when the y changes? So I have to have these two change words in there. It will either be increased or decreased depending on whether your slope was positive or negative. In this case, my slope is positive. So when x increases, y increases. I also have that wishy-washy word again, that about word, because this isn't the exact slope for all babies everywhere. This is just a slope that I calculated from my sample of 100. So it's a prediction. It's an estimate. And then, of course, we have our x and our y variable in words in our sentence, with number of months and length. So to sum up, when we're interpreting slope, we talked about on average. It's not all the time. On average, when the number of months increases by 1, the length of the baby increases by about 2.04 centimeters. Let's make a sentence frame for this that we can put in our notes to use in any situation. On average, when the blank increases by 1, the blank by about blank. Let's fill in those blanks for your sentence frame. On average, when the x variable increases by 1, the y variable in words increases or decreases depending on whether your dots are going down or up by the value of b. B is whatever your calculator gave you as a slope, or whatever you're given as a slope of your least squares regression line. Let's try another example. In example number 3, given the data provided describing hours studied for the final exam and the percent score on the final exam, complete the following. A, find the least squares regression line. B, interpret the y-intercept in context of the question. And C, interpret the slope in context of the question. You actually already found the LSRL in the lesson titled, What is an LSRL? If you want to use that, that's fine. But I wanted to bring it in a little bit of practice so that we can make sure that you're 100% confident with that. Pause the video, try this on your own. Click play when you're ready to resume. Let's take a look at the solutions. For part A, the least squares regression line is score hat equals 62.714 plus 7.143 hours. I did that on the calculator, and here's the calculator screenshot. The new part is interpreting the y-intercept. For part B, we need to interpret the y-intercept in context of the question. When a person studies for 0 hours, their percent score on the final will be about 62.71. Notice, I have all the parts of my sentence frame there. For part C, we need to interpret the slope in context of the question. On average, when the number of hours studied increases by 1, the percent score in the final will increase by about 7.14. Now, I know we're thinking about this very structurally. Here's your sentence structure. Fill in these blanks. I want you to be able to do that so you communicate properly, but I also want you to think about what's going on in this question. If you study for 1 more hour, it looks like your grade will increase by about 7%. So looking at this distribution in this particular case, it might behoove you to study for 2 more hours so that you can increase your percent score by 14%. Now, that doesn't mean that if you increase by 2 hours, your score will go up by exactly 14%. Remember, this is an estimate using a sample of data. But it gives you a good idea that if you study more, then your chances are better to get a good grade on the final. That's really what interpreting the slope is talking about here. Now let's test what you've learned so far with a check for understanding. The least squares regression line, or LSRL, describing the time a candle burns in minutes and the length of the candle in centimeters, is found to be length hat equals 6.195 minus 0.384 burn time. Based on the information provided, complete the following. A. Interpret the y-intercept in context of the question. And B. Interpret the slope in context of the question. Try to do this without looking at your sentence frame first. And then if you have to, look at it for reference after to check your work. Pause the video to work on this. Click play when you're ready to continue. Here's a check for understanding solution. For part A, interpreting the y-intercept, when the burn time is 0 minutes, the length of the candle is about 6.195 centimeters. And for part B, interpreting the slope, on average, when the burn time increases by 1 minute, the length of the candle decreases by about 0.384 centimeters. One more time. Let's look at the big picture rather than just structurally. This is saying, before I light my candle, it's probably about 6.195 centimeters long. And then after I light it, for every minute the candle burns, it loses about 0.384 centimeters in length. Pretty reasonable. Now it's time for the wrap-up. After this lesson, you should be able to interpret the y-intercept of a least squares regression line in context of the question, and interpret the slope of the least squares regression line in context of the question. That concludes our lesson on interpreting slope and y-intercept. Remember, you can review this video as many times as needed for better understanding. Thanks for watching.